So I'm recording now, last class of the week. This is a good opportunity to finish chapter 1. This was a pretty long chapter. If you can see in the bottom corner of my screen, ignore the activate windows. I'm going to go into work on Sunday and bring it to IT and see what they can do. But this was, almost 90 something slides. So pretty big. Some of the other chapters aren't as big as this. But one thing I want to mention is a topic or concept that we have been talking about, or I've been hinting about this for a week or two now. I've talked about atoms, protons, and electrons, and I have always mentioned that atoms are neutral, meaning they have equal protons and equal electrons. And what that means is there's no charge on them. They are completely balanced and neutral. But you might have heard me talk a few times about ions, this word ions. And this is probably one of my favorite definitions. It's straightforward, one sentence, and it's the perfect definition. Ions are formed when a neutral atom, so, a regular atom, an isotope, an element, whatever you want to say, gains or loses electrons. And I have this example on the bottom of an example you hear me talk about all the time, the formation of table salt, right? And I'll explain what's happening with each of these atoms in a closer look on the next slide, or next two slides, I should say. But one thing I really want you to notice, and we'll come back to this in chapter 3, but in this type of situation, the electrons are getting transferred, okay? And there's a law in chemistry and physics, there's a few laws, but a law you hear about in chemistry is the law of conservation of mass, or the law of conservation of energy. And it's a law in science that states that, in the universe, we cannot create or destroy things like mass or energy. What it really means is the energy is conserved. And in simple words, what I'm trying to say is when the sodium atom here loses an electron, it doesn't just vanish into nothingness. It doesn't disappear. That electron has to go somewhere. And what happens when you mix sodium and chlorine together in the right circumstances, you might need some energy to help it, but that electron gets transferred, which means given away to the chlorine. And this type of bonding we'll talk more about in chapter 3, but it's called ionic bonding, and it's different than like how something like water would be formed, H2O. That's a different type of bonding. So we'll learn more about that in chapter 3. And actually, most of this you can kind of just keep in the back of your mind for right now. We will come back to this in great detail in chapter 3, because we're going to learn about bonding and naming and things like that. So let's look at each atom and see what's happening here. So the sodium atom has 11 protons and 11 electrons, and I know that because of the atomic number. That's the number on the top of your periodic table, or I should say on top of the element on the periodic table. So I'll show you where these numbers come from in the example. Okay, we won't get into the details yet of why it loses one electron and why it even loses them anyways. That's in another chapter. But it does have to do with the valence electrons, and we'll come back to this a little later. So sodium typically, loses one electron. So I want you to look at the atom over here, or I should say the ion over here. Think of the balance here between these numbers. Think of this like a math problem. If you had 11 positive things and 10 negative things, and you added them together, the number you would get would be positive 1. And that's why this sodium ion has a positive 1 written up there. We usually don't write the number 1 if we don't have to. Like in math, you don't say 1x, you just say x. So this plus means it has 1 more proton than electrons. If it was a 2 plus or a 3 plus, it would have 2 more or 3 more. And I'll get to this in this page or this slide. We'll talk about this. The only other thing I guess I should mention is we name ions based on their charges. There's 2 types. We have positive and negative. Positive are named cations, and negative are named anions. And I can show you a little hint after I do the next slide. So we're almost done, just a couple more little bits of information, and we're going to practice some of these next. Okay, chlorine, 17 and 17, that is the atomic number like I mentioned. So it's the number above the element on my periodic table. I won't get into the reason, but chlorine tends to gain electrons. It absorbs or attracts these electrons. So go over here, 17 protons, 18 electrons. Let's do the math. Positive 17 minus 18, you would get negative 1. So that's why we call it the Cl minus. This has a special name. It's called the chloride ion. We'll talk about that later. But any negatively charged ions, we call them anions. For any students in this class that are going on to Chemistry 2, so chemical engineering or medical science, so health and safety, or most students except mechanical or maybe a few others will do Chemistry 2. We'll talk about this a lot in Chemistry 2 because there's a unit or a chapter called electrochemistry, and we'll talk about cathodes and anodes, and it's really, really interesting. It's basically how batteries work. It's pretty cool. There's one thing I'll mention, then I'm going to show you a little trick to remember the names, and then we'll do practice problems. The one thing I want to mention here is protons cannot change. Now, I don't mean it's impossible to add protons to an atom or remove protons. There's really crazy chemical or nuclear reactions that do this, but that's not for Chemistry 1. That's, maybe in physics or something like that. So protons do not change. So when you're looking at the charge, and I'm saying charge, I mean this number here, I'm working at the bottom of the slide here. When you're calculating the charge, positive, negative, the only thing that you can change in an atom is the electrons. Protons have to stay the same. If my protons changed, this would not be chlorine anymore. It would be something else. So I can't change protons, and we are not getting into that, as far as I know, in this course at all. This idea of like fusing atoms together to increase their protons, that's not for us. So let me show you something. I have a message in the chat. Oh, Abdullah, I probably will teach Chemistry 2 for chemical engineers. I might teach you in Chemistry 3. That's the hydrocarbon chemistry. I never know what I'll teach. So I typically do teach Chemistry 2 though. Okay, let me show you something. And if any of you are confused, where am I getting atomic numbers? Where am I getting all these numbers? I'm going to show you in a minute. But this is a way I always remembered that cations were positive and anions were negative. the word cation, I did this in my last class too, has a plus sign in it. Cations are positive. Okay, anions, I don't have any tricks for that. All you need to know for anions is if the cation is positive, the anion is negative. If there's no charge, it's not an ion, it is an atom. Okay, isotopes can also have no charge. So the way I always remembered this, cations, the T is like a little positive sign. So that's my positive one. All right, so let's do some examples. This, I hope, will make sense in a minute. I regret my first example because we already did it. Maybe I can change it. What's another cool element we can pick? What do I want? I want to pick a cool one. Let's pick aluminum. No, let's do it. Let me do a hard one for you. And when I say hard, it's not actually that hard, but this wouldn't be as easy as sodium. So I'm going to keep these three the same. There's nothing wrong with them. The only reason I'm not going to do sodium is right here. We already see the answer. So I'll pick a new one. Okay, so first things first, I need to get the atomic number of all of these elements. Okay, in order to do this question, you have to know your atomic numbers. Luckily for you guys, you do not have to memorize this. Okay, this is all in your periodic table. So let me open up my periodic table and I will get the atomic numbers for all of these elements, and then we can get started. So let me open up my periodic table here. I'm talking to myself as usual. Okay, ladies and gentlemen, what I've just shared my screen. This is your data book. These are outside my office, building 7242A. Okay, 7242A. All right, and most of this data booklet you will not need for now until the until a couple extra chapters. All right, sorry, just reading the chat in there. All right, so let me scroll down. Here's our lovely periodic table. Let's get our numbers. The elements, which I've already forgotten, but I think I have them written down. Yep. We have aluminum. Whoops, sorry. Get my pencil. Aluminum, atomic number 13. We have strontium over here. Big atomic number for strontium, 38. I have sulfur at 16 and phosphorus at 15. So that's it. That's all the information I need to do this question. So I'm going to go back to my notes. Okay, and let's write the atomic numbers down. So aluminum was 13, strontium was 38, sulfur was 16, and phosphorus was 15. All right, so let me do one. I'll give you guys a couple minutes to try the other three, and that's basically it for today. All right, so the ions. I'm trying to figure out the number of protons and electrons for each of the ions. Now, I know the question doesn't mention protons, but it's good to just make a note here. So aluminum has 13 protons. Somebody in the chat already said the answer, by the way, so that was really good. So the question is, how many electrons? Well, the charge here, and I'll tell you in chapter 2 where the charges come from. Some of the charges are written on the table, some you kind of have to figure them out, but we'll worry about that in another chapter. But I know that there's 13 protons. So how many electrons would I have? Well, it's positive 3. So I must have 3 more protons than electrons. The 3, and we write it in chemistry with the number first, then the plus sign, because this technically isn't a positive 3 like you might see in math. What this means is 3 positive things. So this ion has 3 more protons than electrons. If you go to the next example, strontium would have 2 more protons. If you go to the next example, sulfur would have 2 more electrons. And again, that's why in chemistry we write it 2 negative things extra. So the answer here is 10 electrons. And you guys can always check your work, because I could just go 13 minus 10, that's positive 3. So it works. I get my answer, positive 3. So one thing I'll mention, and then you guys can get started, is just remember the cations, these are the top 2, they're positive. They have more protons. The anions, they're negative. They have more electrons. Just note though, I am not allowed to change my protons here. Okay, so you can't touch the protons. You can only touch the electrons. So I am going to mute myself. Let me read the chat first. Okay, Tarek has in the answers, or in the chat, I think, the answers. I'll talk about them in a minute, but I'm going to mute myself. And I'll give you guys just maybe 2 minutes to finish this. This is definitely test question, multiple choice or something like that. So I'll mute myself and I'll be back in 2 minutes. You can also put the answers in the chat if you want. You don't have to. All right, I'm getting lots of answers here. Mostly correct, and Hania, sorry if I'm saying your names wrong. You got the right answer, you fixed it. So it is 18 for C and D. Tasneem just sent me the right answer. I mean, Shiraz, lots of right answers. Tarek, again, perfect answers. So, okay, I was gonna say something, but I'll say it in a minute. I'll write the answers down first. There's so much I want to talk about, and there's so much I could say, but it's in other chapters, so there's like no point in getting ahead of myself. But some of these numbers, the reasons they are what they are really cool, really cool. So let's get the answers here. Okay, so first, sorry about that. Let me write down my number of protons. I'm not changing anything. I keep the numbers the same. You cannot change protons. All right, so it's electron time. And like I mentioned, this is a good, multiple choice question. I might give you an ion and say, calculate the number of electrons, or tell me how many. So, let me make sure I'm recording. I am. B. I'm getting lots of answers here. 36, that would be correct. Remember, the positive 2, let me pick another color. Boop. Let's go with purple. The positive 2 literally means that I have 2 more protons than electrons. So I would remove 2 electrons from this. All right. And again, you guys can always check your answers, okay, because 38 protons minus 36 electrons is positive 2. Okay, now mathematically the integer is positive 2, but again in chemistry we always say 2 plus, because what that number represents is that there are 2 more protons in this atom, or in this ion. Okay, so down here, this is the opposite of what we just did. Now I have 2 more electrons. So I'll add 2 electrons to give me 18. Remember, guys, the electrons in the atom match the number of protons. So I'm starting with 16 protons and 16 electrons. So this number here, 16, this means protons and electrons. This 15 means protons and electrons. I probably should have mentioned that. So the next one, it's a -3 or a 3 negative. There's 3 more electrons than protons, so this is also 18. Okay, and you can check any one of these if you want. So let's just check the last one. 15 minus 18, -3. All right, it works. There is a reason why they are both 18. There's a really good reason. It's called the octet rule, which we'll talk about in another chapter. Again, I could talk about this for like 10 hours straight and never run out of things to say, but I'll leave it at that for today. Let me just check the chat and I'll show you one more thing before you all leave. Abdullah, do you want me to do the last one or are you okay? Oh, okay. Yeah, do you want me to do it again? You have questions, okay. Ask your questions away. No problem, you can type them or turn your mic on, whatever you want.
Master?
Yeah.
Master, you said the proton and the electron are equal, yeah?
Yes, in an atom, not in an ion, but in an atom.
When the ion are different.
Yes. So, you know, if I look at, so just look at the bottom of my slide here. If I look at this 15, the atomic number is 15. What that means is the atom of phosphorus has 15 protons and 15 electrons. The ion of phosphorus, and I'm circling it there on the left, it has a -3 or a 3 negative. That means I'm going to add 3 electrons here. And that's where the 18 comes from.
Okay.
Yeah, and if any of you guys want more work or practice, there are practice problems on the worksheet with answers.
Okay, thank you, Mr.
No problem, no problem, no problem. Okay, so before you all leave me and have a good weekend, I just want to show you something. Ooh, I logged out. This is going to be interesting. Okay, give me a second here. I'm going to log into my D2L. This is only 1 minute work, guys. Don't worry, you'll be out of here in a very quick time. For next week, so there are labs next week. You do have to come to the lab. But for next week, when you have class with me on Monday, we just finished chapter 2. So your notes, and I'll share my screen now. I just had to log in. If you click on content, I have more notes here and I'll show you. I did this a month, not a month, but 3 weeks ago. I showed you this content, lecture notes, and I have unit 2. Unit 2, this is a PDF document, printable document format. If you don't want to print your notes, you can just go along with the PowerPoints with me. If you don't have Microsoft Office, it doesn't matter. The top one, will open in Internet Explorer, Safari, Google Chrome, whatever web browser you have. You can open the top one, okay? And the bottom one is the PowerPoint. If you do print them, you'll notice that the printable PDFs are nice big slides, 2 per page. So there's lots of room for you guys to write. And we will be doing chapter 2 on Monday. All right. So that's it for me. I'm going to stop my recording. If you guys have any questions, let me know. If you don't have any questions, have a fantastic weekend, and don't forget to wash your hands and wear a mask.